Hello everyone, I am starting with periodic table. Periodic table. Periodic table is divided into 18 groups and 7 periods. Horizontal rows in periodic table is known as periods. Horizontal rows in periodic table known as periods, and vertical columns in periodic table known as groups, and these are divided into 4 blocks. S block, P block, D block, and F block. S block consists of element in which last electron enter into s orbital. Its outermost electronic configuration is ns2. P block, in which last electron enters into p orbital and its outermost electronic configuration is ns2 and p1 to 6. D block, in which last electron enters into d orbital and its outermost electronic configuration is n-1 d 1 to 10 ns 1 to 2 or n-1 d 1 to 10 ns 0 to 2. F block, in which last electron enters into f orbital and their outermost electronic configuration is ns2 n-1 d 1 to 10 f 1 to 14 या फिर ns2 n-1 d 1 to 2 0 to 2 1 to 2 f 1 to 14. S block, now I'm starting with S block. S block is divided into 2 groups: alkali metals and alkaline earth metals. Alkaline earth metals. These are called alkali metals because they form oxides or hydroxides. And these are called alkaline earth metal because their oxides and hydroxides are alkaline in nature. Alkali metal belong to group first and alkaline metal belongs to group second in the periodic table. Now group top to bottom, horizontal, vertical columns are known as rows. Group first and group second. Group first consists of hydrogen, lithium, sodium, potassium, rubidium, cesium, francium. Group second consists of beryllium, magnesium, calcium, strontium, barium and radium. This belongs to francium and radium belongs to 7 period and these are radioactive in nature. Hydrogen belongs to first period. Lithium and beryllium belong to second period. Sodium and magnesium belongs to third. Potassium and calcium belongs to fourth period. Rubidium and strontium belongs to fifth period. And cesium and barium belongs to sixth period. At last, francium, radioactive element francium and radium belongs to 7 period. Outermost electronic configuration of group first element is ns1 and group second element is ns2. When we move from left to right, there are p block elements from group 13th to group 18th. Group 13th, 14th, 15th, 16th, 17th, 18th. 18th, helium, neon, argon, krypton, xenon and radon. 17, group 17 belongs to halogen, fluorine, chlorine, bromine, iodine and astatine. Group 16 belongs to oxygen family. Oxygen, sulfur, selenium, tellurium, polonium. Group 15 belong to nitrogen family. Nitrogen, phosphorus, arsenic, antimony and bismuth. Group 14 belong to carbon, carbon, silicon, germanium, tin, lead. Group 13 boron, aluminium, gallium, indium, thallium. This is the radioactive element. Group 17 period 7 period belongs to radioactive elements. And its group 13 boron family has outermost electronic configuration ns2 np1. Number of valence electron 3. Carbon family it form boron family it form 3 bonds. Oxidation state varies. They have variable oxidation states. Carbon ns2 np2, nitrogen ns2 np3, oxygen ns2 np4, halogen ns2 np5 and noble gases ns2 np6. They have number of valence electron 3. Carbon family has number of valence electron 4. Next, when we move from left to right, electronegative character increases. Fluorine has outermost 7 electron. It requires 1 electron to complete its octet. According to octet rule, in outermost electronic configuration of fluorine is halogen family is ns2 np5. So it has 1 2 3 4 5 6 7 electron. So it requires 1 electron to complete its octet. And these are electronegative in nature. For example, in hydrogen there is only 1 and fluorine there is 7 electron. It can take electron from hydrogen and become negative, acquire negative charge, and hydrogen acquire positive charge. As hydrogen, which belongs to S block, is electropositive in nature, and hydrogen electronegative in nature. Hydrogen, by losing one electron, form lithium, by losing one electron, acquire positive charge. Sodium, by losing one electron, acquire positive charge. They are electropositive in nature. They are electropositive in nature, and bond formed by them is ionic bond. And as they by they I for example, in case of HF, by losing one electron, it acquire positive charge, and fluorine acquire negative charge. Octet of fluorine is now complete and hydrogen is stable. So bond between them is HF is ionic bond. Bond formed by oppositely charged ion is known as ionic bond. Bond formed by S block element is mostly ionic bond. And as they form positively charged ion, they act as reducing agent. Electropositive nature is the characteristics of metal. As we move from left to right, when we move from left to right in the periodic table, electropositive character decreases, and electronegative character increases. Tendency to acquire electron increases, and tendency to give electron decreases. So tendency to give electropositive character decreases means reducing character decreases. On moving left to right, reducing character decreases, and oxidizing character increases. And from moving top to bottom, when we move from top to bottom, for example, the hydrogen and helium, these belongs to first period. In first period, number of shell 1, and in lithium, beryllium, boron, carbon, nitrogen, oxygen, number of shells, it belongs to second shell. So number of shells, 2 number of shells. And size, as the number of shells increases, size of atom increases. And from potassium, calcium, aluminium, silicon, phosphorus, sulfur, chlorine, argon, number of shells 4. Next, 5, 4, 5, 4, 5, and sixth period, 6, sixth period having maximum size, and seventh period elements belong to radioactive elements. They are unstable, so B cannot include in this properties. So as we move down the group, top to bottom, atomic size, atomic radii increases, atomic size increases, and as we move from left to right, the electron enter into same shell. Electron enter into same shell. So in case of hydrogen, electronic configuration is for number of shell 1, belongs to s orbital, and number of electron for group first is 1. Helium belongs to first period, s block. This is an exceptional case for helium. Helium has fully filled electronic configuration, so it belongs to noble gases, but it belongs to s orbital. Last electron enter into s orbital. 1s and 2 electron filled into it. Fully filled electronic configuration. So number of first shell s orbital and number of electron in hydrogen is 1, and for helium first shell number of electron 2. As the number of electron increases, effective nuclear charge on nucleus will increase. And for lithium, there is 3. Lithium belongs to second shell s orbital and having 1 electron. So we can write for lithium 1 shell, before 2s orbital there is 1s orbital, and 1s orbital, first shell is filled, and in second shell there is only 1 electron. As the electron increases, effective nuclear charge on nucleus increases by 3. So say जितना चार्ज इलेक्ट्रॉन न्यूक्लियस पे, जितना चार्ज इलेक्ट्रॉन का होगा उतना ही चार्ज न्यूक्लियस का होगा. चार्ज ऑफ इलेक्ट्रॉन बैलेंस्ड बाय चार्ज ऑफ न्यूक्लियस. नेक्स्ट बेरिलियम. This is for lithium and this is for beryllium. Beryllium 1s is filled having 2 electron, and beryllium is also filled having 2 electron. And in case of boron, boron having outermost electronic configuration ns2 np2. ns2 and boron belongs to second shell. Second shell s orbital is filled, and for p orbital it is also filled in same shell, and p orbital it has 1 electron. So for boron first shell 2 electron, and in second shell there is 3 electron, 2 of s orbital and 1 of p orbital. 1 2 3. So as we move from left to right, charge on the nucleus increases by 1. So 1 2 3 4 5. So charge on nucleus increases by, and the size decreases. Left, as the charge of the electron will enter into same shell, and charge on the nucleus increases, and this will attract outermost electron towards itself, and size of the atom will decrease. Left to right, size decreases. As the size decreases, ionization enthalpy increases. Ionization enthalpy is inversely proportional to size. And as we move from top to bottom, number of shell increases, that is atomic radii increases, size increases. It is difficult to remove an electron from it is easy to remove electron from an atom because of distance from nucleus to the outermost electron. There is large distance between electron and the nucleus, so outermost electron feel less effective nuclear charge and can easily lose electron. Hence the ionization enthalpy decreases down the group. Ionization enthalpy decreases down the group. And left to right, ionization enthalpy due to extra nuclear charge increases. So this is the concept, and p block elements form, bond formed by p block element is covalent bond. Covalent bond. Bond formed by sharing pairing of electron. For example, O2. Oxygen has how many electrons? Oxygens have in outermost cell? 6 electrons. 1 2 3 4 5 6. It required 2 more electrons to complete its octet. So by sharing of electron with oxygen, these electron, it formed 2 covalent bond. 1 2 3 4 5 6 7 8. Bond formed by sharing pairing of electron is known as covalent bond. And for D block element and F block, I will discuss these in later. Thank you.